Welcome to the online class for the Replicator tool. In this class, we'll be covering the number of tools that are necessary to perform replication successfully, as well as some typical and very useful locations in an application where you can take advantage of the Replicator tool. The first thing I want to do is show you the Replicator tool in action. And one of the nice things about this Replicator tool is the fact that you're going to be able to perform a lot of really neat things on the fly. Let me show you what I mean. What you're seeing here is a rather simple setup, and I'll let that load on your screen. And that setup is of a key that is trained, and the job of this particular product is to simply find the key and make a measurement across the key's length. And the idea here is that we want to use the replicator in order to automate a lot of the things that we would normally not have access to. So that if I know the number of keys, that might not be such a big deal. Maybe I have one, maybe I have two keys, but I know that it's always going to be two keys. I might not need to use a replicator because I can just set up one of my tools to find the two keys and make measurements. But what if I had one key, or two keys, three keys, four keys, who knows how many keys? What I can do is I can start introducing keys into the screen, and what you're seeing here is the replicator in action. If you find one key, for example, right now, it will go ahead and perform its function over that one key and give you the information. If you find two keys, it can go ahead and replicate the tools that you're using on the original key and perform that once again. Add another key and yet another key. You start to get an idea of the power of this tool, where we don't have to go back in and reprogram our tool setup or get into scripting just to be able to duplicate those same sets of inspections on multiple different features of the parts. So once we have this set up, we can actually go ahead and view the results for each individual iteration. Let me show you that very quickly. If you take a look down at the results table right now, I'm grouping my results display by different criteria, and you'll have access to this when you set this up. But one of the things that I can do is I can actually group by replicator and tool, and what you're seeing here is that based on my replication completing successfully, I can show all the different parameters and all the different measurements that I'm making for each one of these keys. Okay? So that if I am to take out one or two keys out of here, you'll notice that I only have results for the two keys that are actually being used. So let's talk about what's going on here, how we make it happen, and then I'm going to start to put that same application on the screen. We'll solve that the same way you see here, and then I'll just jump into something a little more complex, but still really neat. So in this particular section of the class, we're going to learn basically the tools that we're going to need in order to make good use of a replicator tool. We're also going to learn about common replicator tool applications, the building methods for a replication tool, and we'll also going to go ahead and describe the tools that you're going to want to use in order to build up to a replication and make it happen successfully. And then finally, we'll talk about the way you analyze results and the way you get those results displayed, which you've actually seen just a little bit of up to now. So let's talk a little bit about replicator applications. I think you have a good idea about what it's going to take to make happen and where something might be of use to you, something like a replicator. But it really comes down to an application that has either discrete parts, like those keys that I was showing you, that show up in an undefined or unknown number. So if you have one or two keys, three keys, you just don't know. That's going to really help you. And you can see that in the bottom left-hand side, you see my key example. You have some other parts in the bottom right-hand side, and on the top left-hand side as well. You see some of those parts that would be very useful because you have discrete parts. Now there are other instances where it will also come in handy, and that is when you actually have a part, but that part doesn't repeat. You'll notice that I only have one gear here. Well, there's a particular feature within the part that does repeat, however, and what I'm hoping to do is use the replicator, and we'll actually set this up, to analyze the individual features of one single part. Okay, so that's actually pretty neat, so we'll take a look at that as well. The first thing that we should do is talk about the way the replication works. And one of the things that is integral to the setup of a replicator is the fact that you have to perform counting at some point. And one of the things that you're going to run into is that although you might be tempted to use any other tool, you're going to see where it really makes sense to use a replicator tool. But really you want to know that it's based on the counting of features so that you can dynamically set your tools to become active or inactive, and then you can also individually, for every one of those features that you replicate, check the tolerances of those tools that you're replicating. The big picture here, I want to show you that you're going to find your setup to display your replicator tool under the counting. So that's one of the things I like to point out to folks, because it's one of those tools where you may not know right off the bat where to find it. And it is so closely tied to counting, and I believe that's why the R&D group, the engineers that are working on the product, dropped it into that category. You're going to find it under counting alongside your count along lines, count in area, and pixel counting. It's just under there. It's called the replicator tool. So take a look in there when you want to look for it. But before you actually look for that tool, let's talk about the things that need to happen first. You need to have an application that's going to make use of it. And the basic premise is that you're going to train on one item or one feature, do inspection on that item, and then you're going to have that replicator copy or replicate, for the lack of a better term, those tools that are necessary. And it's going to avoid a lot of work in your end so that you don't have to either go to scripting and try to script something out to figure out the count first and then enable and disable a finite number of tools. For example, you might have to actually create 20 tools and then just enable 10 of them to work at once. So it's going to cut that out of your workload. Here's how we set it up. The first thing you want to do is use a position tool to locate the part. Now this is especially important if you have a particular part that is going to be the same. You're only going to have one. See my top example there in the images? But the truth is that that part is going to shift just slightly around in that image, or maybe significantly in that image. You want to be able to zero in on that part before you go ahead and perform anything. And that's typical of most machine vision applications. You do want to find and locate the features of interest first. So I put that down as optional because there are some inspections where you don't really need to do something like positioning. So you may not have to do that, but oftentimes you will. Number 2 reads, use a counting tool to determine accurate number of parts or features to be replicated. And in my second set of images just below that, my key example there, you notice that the second and probably the most important part of a replication application is to get that feature or that part counted, because what your replicator is going to do is use that count. So number 3 states, add your replicator tool now and use the counting tool as the source of positions, and you'll actually see that very label when you set up the replicator tool, so keep your eye out for it. Number 4, add tool that will be replicated based on the counting tool's results. So once you get that replicator going, what you can do is you can actually just continue to add more and more tools that will be replicated. And we'll show how to connect those in just a moment. But the idea is, if you look at the bottom image there, it is showing you that we can actually perform the building of one tool and have the replicator actually build those tools out for us without us having to go ahead and get those rebuilt every time. And that's step number 5, repeat the addition of tools. The first thing we're going to do is we're going to set up a positioning tool. In this particular example that I will use in just a moment, it's a little bit more complex, but it's still really useful to see. Even though they are the same part, their position changes slightly, so we need to be aware of that when we position our tool. So we are going to perform that. The next step is to perform our count. This is the cornerstone of the replicator tool. And what it comes down to is that the replicator tool requires a counting tool to have been established prior. Okay? Once you get that count performed, you're going to create a replicator tool. The replicator tool is going to, first of all, prompt you to designate where it's going to be placing itself. You're seeing just a little graphic there of the axis. That's where I chose to place this replicator tool. And the replicator is going to use the count as a source of positions. And you're going to see that right within the replicator tool's properties. You're going to see source of positions, and you're going to use that pull down to select the count that's supposed to represent the number of features that you want to replicate. And then you want to add other tools. And the most important part about adding those other tools is that when you state their position reference, although it may be tempting to reference a positioning tool, because that's what we're really mostly used to, you're going to want to look at the position reference and reference the replicator tool, not the positioning tool. The replicator tool is going to serve so that it is created for each one of those iterations, is what we call them in the program. So if you take a look at the left graphic there, you'll see that my position reference is set to REP. That's what I named my replicator tools. And in this case, it was called rep spokes. And that way, you're seeing the graphics there. Those particular tools are going to be recreated on the fly for each one of those spokes that are detected. To view individual replicator iterations, once you get that replicator and those tools established, you're going to want to head down to your results table and group your tools by replicator grouping. Right? Initially, you'll notice that you'll actually just get one listing for each tool, which at first might not make a connection with you, because if you find 25 spokes, for example, you're going to want to see what each individual spoke measurement is. Right? So at first you only see one. Well, by choosing to group by replicator and tool, you'll start to see each one of those results. All right, so what I want to do now is I want to jump back into Intellect. And within Intellect, I'm actually going to go ahead and go ahead and delete this product, one that I was just working on with you. And yes, I want to go ahead and delete this product. And what I'm going to do now is I'm going to go ahead and create a brand new application, and I'm going to add some replication to it. This one's going to be relatively short and simple, but that's what I want to do right now, just so we can get the major points across. Let's jump over to the counting set of tools. Remember, I mentioned that was the most critical or the most important part of replication. Let's go ahead and perform a count. I'm going to go ahead and perform an area count around this particular portion here. The first thing that's going to happen is I'm going to get prompted for a product name, which is fine. Let's go ahead and add that. It's product keys here. I'll go ahead and click OK. I'm going to go ahead and draw my counting by area region right here. And I'm going to name that. I'm going to name that count keys. The next thing I'm going to do, see if I can show both of these to you at the same time. Yeah, I can. Let's go ahead and make our way down to shape, because under shape, I want to make the search region here, I want to make that take up the entire field of view. So I'm going to move these areas there. I'm searching over the entire field of view for that one key that I trained. Let's go up to options. I'm actually going to make this object locate. These settings that you're seeing here should work just fine. In fact, you can see that I'm going to work just fine here in my results here. I can show you that I'm getting really nice outlines here. So I'm going to leave that there. Model object has been learned, and here are my two components of that model. So this time, what I'm going to do is really jump into parameters, and I do want to be able to account for the fact that these keys may not always fall in the same orientation. So I am going to try to get some accurate positioning here, but most importantly, I'm going to go over to limit rotation, and I'm going to go ahead and make that 180 plus or minus. Now if I apply that, I'm basically setting myself up very nicely so that if these keys are to be presented over the camera, and really any orientation, I should be in good shape. So let's go ahead and click OK, and I've got counting performed. Once you see counting here, what you'll be able to do is problem with the audio there. Okay. Now, let's go ahead and look at the count results, which we have two of. And what we want to do now is actually take a look. We're going to look for the replicator tool. Once we've got that count performed, we're ready to replicate. Let's go under counting again. And I've chosen the replicator tool. The first thing I want you to notice is that my cursor, you see that cursor? Shouldn't look like any other cursor you've seen, unless you've seen the replicator tool before, of course. What it's asking you for is to pinpoint your position at which you will start to count the replications, the iterations. So I'm going to choose this key right here, and you will notice that this axis-like graphic shows up, and I get to set my replication tool parameters. So let's go ahead and do that. I'm going to set the name to be rep keys, as in replication of keys, and my position reference is going to come from the system frame. Now, if you're looking to replicate, you want to actually make sure that you choose your source of position. So let's go look under there and see that count keys is available. So I'm going to use count keys. I'm going to apply that. And as soon as I apply that, it's a little subtle, but I want to make sure I show it to you. Take a look at the graphics that you're seeing here. For each one of those iterations that the replicator is taking advantage of, you should see this yellow crosshair almost. You can see that there on both of them now. This one is a little obscured by the axis, but you should be able to see that on 2 keys, 3 keys as I add them. I'm still working with 2 keys here. Once I set that up properly, I can go ahead and OK it. I have successfully created a replication tool. My next step is to go ahead and perform whatever else I'm looking to perform based on replication. And in this case, the only thing I was attempting to perform was to go ahead and measure the length of these keys. So I'm going to go ahead and go into measurement, and I'm going to measure along a line. And as I measure along the line, I'm going to draw my graphic from one end of the key to the other, just like this. And you should see that that's nothing new there. This is just a measuring tool that is going to measure from this first point as it defines a transition to this last point. Let's go ahead and name this and set the properties up correctly. Let's name it measure key length. And I'm going to make that enabled. My position reference, even though you might be tempted to look for a positioning tool, you're actually going to look for the replicator tool because you want this particular tool to be replicated each time a key is counted in the field of view. So let's go ahead and choose rep keys. Okay, and as soon as I do that, I'm going to go ahead and hit apply here. And what you'll find is that as soon as I hit apply there, once I make my position reference selection for my replicator, those tools will be replicated. You'll see that it appears where I originally placed it, and it also appears in the other example. Zoom out a little bit so you can see that there. And down at the bottom, you can actually select the different replicator iterations is what they're called within the program. So if I want to go ahead and set this up, I can click OK. And that's exactly what's happening here, what we originally saw, where I was able to look at 2 keys. Perhaps I can insert a 3rd key in here and have that replicate just fine and show me the results. Now I also mentioned, what if you wanted to see the individual results? Because what you're seeing right now is actually the average results. If you're looking for the 3 iterations, you're going to want to head over to your results table that you see here. And in that value, that group, I want you to make that go down to, you can start by group by replicator. And what that will do is, it will show you the individual replicators and the individual tools within that one replicator. But what if you wanted to see every single tool, not just the set of tools that are within each replicator? Let's move down to group by replicator and tool. That'll get you the tool values displayed right out into your results table. All right, I have one more example for you. I'm going to load up a product file and some images, and I'll show you something that we're going to expand upon and make work. go ahead and jump right out of here and stop this by disconnecting. I'm going to open up an emulator for the 554 camera. Let that load. And what we're going to do now is we're actually going to go ahead and inspect this particular gear that you probably know are familiar with from our presentation. And we're going to do a couple of things. We're going to make some measurements. We're also going to dynamically make those measurements based on the number of spokes that you see in this gear. So you'll notice that the full spoke gear has 25 spokes, and every once in a while you'll notice that there are actually missing spokes or another gear that actually shows up. And that particular gear actually has 20 spokes. We're going to be able to dynamically set that up. In fact, I already have this running here. I'm going to go ahead and show those to you, show those particular tools running on the fly each time, and I'm going to stop it right here because I want to show you that right now, because I'm using the replicator is taking advantage of the fact that it is performing a count, and that count is actually showing you right down in the results table 20 spokes, and those tools are being replicated 20 times, and you can see that the graphics showing up right up top there. Now if we move on to another image, this particular one happens to have 25 spokes, and what you're seeing here is that the tools are being replicated 25 times. So it really helps us when we have to do perhaps a lot of busy work where we would have to try to figure where these are first of all, and then whether or not we have 25 or 20 of them, and then try to enable and disable tools. I think you get the idea that we're going to be able to do that a lot more efficiently. So what I'm going to do now is, excuse me, I'm going to actually replicate this particular inspection by, well, first of all, getting rid of this one and creating something from scratch for you. So let's go ahead. The first thing I want to do, anybody remember what that particular first step was? It will come in handy in this particular inspection because we need to know exactly where that gear is located. That one is actually, the first step is positioning. So the first thing we want to do is figure out where this gear is. And you can see that there isn't a lot of variation, but there is significant variation if I cycle through these images. It doesn't show up at the exact same location, especially the difference between here and here. That's a pretty significant shift that I'm showing you here. So the first thing that I actually want to do is make sure that I can take advantage of a good gear and a good position, and that I'm able to find where that location is. So the first thing that I want to do is set up my position. Let's go ahead and perform a circle fit. I'm going to perform that circle fit around the center of that particular gear. And the first thing, of course, I want to do is set up a product name. So I'm going to call it CRD gear. Okay, that. And now I get to set up my tool. I'm going to set it up to do something like this right here. As long as I get that center circle inside the center of that particular gear, I should be in good shape. Let me zoom in just a little bit so you can actually tell that I am seeing the graphics there. I'm doing a pretty good job of finding that particular circle that I'm looking for. In fact, you can see what's happening down below. I'm already getting my results. This is good. Go ahead and name this. I'm going to name it position gear, and I'm going to go ahead and really that's all I really need to do for this particular tool. I've already set the shape graphically. I have some options here which are working just fine. I'm looking for the first edge found in that particular direction as I drew it out, and I'm looking for really any edge, but I guess I could get more specific and say I'm looking for a light to dark edge only, and that would rule out perhaps any noise that might shift that particular edge being found. So that's really all I need to do. Let's OK that and see some of those results. All right, I found the position of my gear. Now what I need to do is make sure that I can actually find the spokes or the number of spokes. Okay, so how do I find the number of spokes? Well, the first thing I have to do is use a counting tool. So let's go ahead and do that. I'm going to jump right back to grouping, no grouping, because what I want to do is show you that I want to simplify the list at first, and then if I really need to get into the individual measurements, I can do that as well. So let's go into counting. And more specifically, I want to actually perform a count along the line, but not just any count along the line. I want to use an arc, because the arc is going to allow me to, well, make my way around this gear, count the number of spokes, and feed that into my replicator, which we're about to drop in. So the first thing I want to do is start by creating a count along this arc. I'm going to draw this circle all the way around here. See that? I am making sure that I am drawing that first circle so that it crosses along the spokes. And then the next thing that we do is we actually make our way all the way around here. Okay? And make sure that we can count all those spokes. And as soon as you do that, you should make your way all the way around as close to the end as possible there. Make sure you have a nice circle. And immediately you're going to get that properties to pop up and prompt you for a name. So let's name it. Let's get that out of the way. This is going to be a counting tool, and we're going to count spokes in this case. There we go. Count spokes. And before I said anything else, I just want to show you that you should be looking for some, I guess you could call them visual cues, to let you know things are going okay. I'm going to zoom in and show you what visual cues I'd be looking for right now. I'd be looking for some graphics along these spokes to make sure that my tool is able to find them and detect them okay. So that looks good to me. That's something you should be looking for as you set it up. Let's go ahead and set the position reference. That's going to be the position of the gear that we previously created so that we know where this gear is moving around within this image. So let's go ahead and apply that. Looks good so far. Let's make sure that we're getting an accurate count of spokes, because you'll notice that graphically, okay, there are actually two graphics for each spoke. Can you see that? A red one and a green one? You have a red one and a green one. That just means that one has a transition from white to black and the other has a transition from black to white. That's all that means. But if you take a look down at your results table, you'll notice that my count is 50. And I assure you that if you actually take the time to count those spokes, there are only 25 of them. We're actually counting them twice each time. So let's get a little bit more specific on these properties. Let's head into options. Okay? And we can leave most of this the same way, but what we really want to do is not just count any edge. We want to count a very specific edge. Why don't we go ahead and count a dark to light transition or a light to dark transition, one or the other. Okay? Let's go ahead and count the light to dark transition. Every time this line goes across light to dark, it's going to show a graphic. Let's go ahead and apply that, and you should immediately see that one of those two graphics disappears, and you only keep those that change from light to dark. All right, that looks good to me. We also should notice at the bottom shows me 25 for a count. I'll click OK, and everything's looking good so far. We've got a position completed. We've also got a count completed. Okay? It usually helps, I know it helps me, to make sure that we're looking at the order of execution for my tools and the order at which things are happening. So here's what I want to do. I want to just scroll over just a little bit over to the right in my results table, and I'll do this slowly so you can keep up online. And instead of sorting them by name, let's sort them by order here. So that the first one shows up first, the second one shows up second, and so on. So there you go. I first find the position of my gear with my position gear tool. Next, I count the number of spokes, and once we have a count, we can perform replication. So let's go ahead and perform replication right now. I'm going to jump into the count category, and under the count category, I'm going to look for replicator tool. The first thing that you'll notice is that your cursor will change from most of the cursors that you may be accustomed to. The tool is basically prompting us to set a starting point or a zero iteration, if you will. This will be the home location for the replicator. So let's go ahead and choose one of the tools, like this top one. This top spoke would be a nice sort of general place to start out. Let's choose that one right there. As soon as we do that, I want you to notice two things. Number one, your properties will pop up. Number two, you're going to get that axis that I talked about. So let's go ahead and name this. We're going to name this rep spokes. And we do want it to perform inspection. You may be tempted to choose the position of the reference to be position gear. You don't want to do that. You want to choose the source of positions to be count spokes. And I bring that up because that's the first one you see. You might be tempted to jump in here, I know I am, do this and apply that. But if you notice, if you do that, what will happen is your source of positions will disappear. You can only do one or the other. If you choose this one, then your position reference changes to system frame. If you choose this one, which you shouldn't at this point, you're going to lose your source of position. This is a replicator tool. You're interested in the source of position, so make sure you set that instead. So, count spokes, that's the tool that's going to give me my source of position. If I apply that, okay, you should see, this is a little subtle because we have such a light background here, but you should see up top, can you see a yellow graphic show up every place we find the gear? You should be able to see that from where you're sitting right now. I want to zoom in just a little bit, see if I can help you see that. I think that's even better right there, so hope you're seeing that. And now you should have one of those, not just there, but anywhere you find a gear spoke right here. Okay? So please look into that and make sure that when you're setting up your replicator that you choose a source of positions, and when you apply that you can see those iterations just start to pop up for every one of those gears. All right, so looking good so far. Let's go ahead and OK that. Now I've got position. I've also got a count. My replicator is using that count to replicate any number of tools that I'm going to create at this point. So what can I do now? For each one of those spokes, I can use one tool to dynamically inspect them. So let's find out the width of each one of those spokes. Okay? Let's measure the width of each one of those spokes. I'm going to go ahead and zoom in just a little bit. Okay, this is a rather large image. And let's go ahead and measure first of all. And I will measure along a line. And I'm just going to go ahead and draw a very simple line right across here. See that right there. And this, the only thing this particular tool right now is going to be doing is measuring the distance between one end of that spoke and the other end of that spoke. That's it. So let's go ahead and name this tool. This is measure spoke width. And my position reference again, you may be tempted to use the gear position, but in this case, you don't want to do that. Because we want to inspect each one of these spokes, we want to make sure that this particular tool doesn't just work on this spoke, that it gets replicated over each one of the other spokes that are found in this gear. So for position, I'm not going to choose the gear's circle position. I'm going to choose the replicator that is using the spokes count. So I'm going to apply that, and as soon as I do that, keep your eye on the image because I'm going to do this. And you should see that tool replicated to each one of those. You should see new graphics on the image. Okay? And you should also see a brand new setting that you can make here where you can actually select any one of those iterations, 25 of them from 0 to 24 you see here. So that looks good to me. Let's go ahead and take a look at what's happening in our properties from the results table. You should see a graphic for each one of those spokes right now. Okay? And you can see measuring spoke width here. What else can we do here? Now that we've got this all measured out, we can actually go ahead and perform some more inspections. So here's something else that might be of use to us. Let's measure the distance between the center of the gear to the tips of the spokes. Okay? So the first thing I need to do is make sure that I find the tip of the spoke, right? So let's go ahead and do a position tool here. I want to know the position of the tip of this spoke right here. Okay? So let's go ahead and do that. Position along line. I'm going to zoom in just to show you a little bit closer what I'm attempting to do here. And I'm going to draw this tool right into the spoke. I'm just looking for that white to black transition, like that, and you should be able to see that red graphic there that shows me that it's already been found. Go ahead and name this. Let's name it position spoke tip. And I will go ahead and give it a position reference of the replicator. And as soon as I do that, you should see that tool, boom, replicate and show up for each one of those spokes. All right, let's continue. We've got the position. We've got everything we need here. We can get a little bit more specific if you really want to and say, let's look for light to dark transitions. Not likely to have any other kind of transition there, but we can go ahead and select that, be more specific. And let's go ahead and OK that. We've got the position of the spoke tip all the way around. Let me zoom out just a little bit here. And you can see that here. Each one of those is showing up. The last thing I want to do, if I want to know the distance between the spoke tip and the center of my gear, is actually use another measuring tool. But this time, what I'm going to do is measure with point and line. What that's going to allow me to do is select the location of the spoke tip and the center of my gear and give me the distance between those two. So let's go ahead and measure with point and line. I'm going to call this measure, call it spoke height. Okay. And let's jump into the options and set up an operation of distance. Now we get to choose what tools we're going to be measuring between. Let's choose the position of the gear, which is the center of that circle that we initially set up. And I want to measure between that center and the position of the spoke tip. There we are right there. The position of the gear, which is the center portion of this gear, and the position of the spoke tip, which is each one of these replicators. Remember, they're all replicators. So let's take a look at what that will do. Let's OK it. And what you should see now is a graphic that shows you that we're replicating each measurement between the center of the gear and the tip of the gear. And you can zoom in just a little bit here. You can see that's happening for each one of these spokes. So let's go ahead and cycle through some of these images. Let's see the results. We should see all of these dynamically appear and reappear depending on the number of spokes that are counted. Let's go ahead and go to the next image. Here we go. Let's look at our count. Our count is 20. Well, that means that we should only have 20 of those tools that we replicated showing up. And in fact, you'll notice that wherever we're missing a gear or gear is not found, we are not setting up one of those tools. We don't need to. There's no gear there to perform that function in. So let's cycle through all of these. Oh, we've got something going on here. What's happening here? Let's jump back just a little bit. Aha! Looks like we've got a gear that has shifted position here. Okay, let me jump back and jump forward again so you can see. Here's the position of the gear. Looking good. We go back to that image. Ouch. We're missing the gear. And I'm pretty positive that it's due to the fact that we're not really catching the circle within the right location here. So we're going to do a couple of things. Easiest is probably just to shift this circle just a little bit to make sure that no matter where this gear is found, we're looking for it. And the center of this region finds itself in the center of that gear, and the outer one finds itself outside of this one. So that should be good. We could even modify that just a little bit, make it a little bit more tolerant there. That looks pretty good. Let's go ahead and enter that. Oh, there we go. Looks much better. We're finding the center. Everything's working just fine like we expected it to. We just missed out on that particular position, but we're in good shape now. Let's go ahead and cycle through those images. Looks good here. Very nice here. Again, 25 gears, 25 tools replicated. Again, 25. There we go. We've just got 20 here. And if you really want to get into each one of those, let me show you how we do that. Remember the grouping. Let's go ahead and group by replicator and tool. You're going to see a whole new setup for your results table here, where you will see the measurement of the spoke height for each one of those 20 replications, right? See that as I'm scrolling down the list there. And then remember, we also measured the spoke width. We replicated the spoke width to see how wide each one of those spokes was. So there you go. That's replicated 20 more times there. Okay. All right. Now one last thing that I should point out is that as you're looking at all of these tools, one of the things that you want to consider is a tolerance or a passing parameter for each one of those tools. Now, if I show you each one of those tools, you'll notice that I can open up, for example, how about we open up the measurement of the spoke height? Well, you know, we might be tempted here to set up a minimum and maximum distance here, which isn't a bad idea. However, what this is actually doing is it's setting up a minimum and maximum which will only apply to the average returned from that replication, so from the average of 20. And that's okay, but if you really want to get down into the individual ones, okay, individual values, you really got to step out of the tool, and keep in mind this section is replication. Well, we really have to jump into the replicator tool. Let's jump in there because I want to show you what you have access to now. Under this tool, what you're able to see is a results list. It shows you the number of iterations. And in this case, we only have 20 of them. And a nice thing that you can also see is that you can actually see each one numbered. Well, I want to go beyond this and want to set the passing criteria for those replicated tools. And if you click on pass, what you'll see is that now you're able to set up the pass and fail criteria for each individual tool that is replicated. This is where you really need to go in order to perform that. So what you want to do here is set up that the replication will, the iteration pass-fail criteria here will pass or fail based on these conditions. And one of them is all of the following conditions are true. Okay? So perhaps you want it so that the width can fail and the height can fail, but the position of the spoke tip must always pass. Okay? And that's what would be counted when we go ahead and replicate and run this environment, this particular product. We can leave that on, or we can ignore that, as you can see there, or we can actually say at least one of the following conditions are true. And what you'll have to find is that each one of these will have to pass or fail, okay, in order for the replicator to pass or fail. So you have to get into the replicator tool here and set up your minimum and maximum pass-fail count in order for your replication tool to actually fail. Like most tools in the Intellect product, it is set to, by default, always pass, regardless of what's going on in your tools, actually. So even if one of your tools, individual tools, happens to fail, your replicator is set to pass. And what you want to do is come in here and set up your options so that your replicator will be set to fail based on the right conditions. Okay, that's really the last thing I wanted to show you, because you want to be aware of it. This is where you want to set up the passing and failing for your replicator. And it makes sense once you think about it. These are the pass and fail criteria for the replicator tool. All right. Well, I hope that has helped you understand a little bit more how the replicator works and the steps that you need to take in order to make it function properly. Now we can actually make our product go ahead and run continuously, and each time that gear shows up, we can find it, we can count the spokes, and we can replicate every tool that we use in order to understand what's happening with those spokes. If you want more information on the replicator tool, you can always take a look at cosmicsensors.com, and under downloads you'll find all sorts of things like all the files and presentations that we use in order to present our materials, as well as everything else like the video of this particular section if you need to catch up on this particular one that you just viewed, or any other ones that we're going to be putting up there. As we present them, we record them, and we post them up so that folks can take advantage of them. Thank you very much, and I hope to see you soon at another one of these online classes, or perhaps in person in one of our live classes. Thanks.